Azure gives you 3 load balancing services that people constantly confuse, and picking the wrong one means either paying for features you don't need or fighting limitations you can't escape. In this video, we build one realistic stack end-to-end, a global web application that needs edge routing, regional web application firewalling, and internal traffic distribution. We'll place Azure Front Door, Application Gateway, and Azure Load Balancer, each where they actually belong, decide why at every hop, and then verify the whole path works. By the end, you should be able to whiteboard this from memory and defend each choice. Start with the mental model. Azure Load Balancer is a Layer 4 service. It routes TCP and UDP by IP and port. It's regional, and it has zero understanding of HTTP. Application Gateway is a Layer 7 service, also regional, that terminates TLS, reads URL paths and host headers, and bundles a web application firewall. Front Door is a global Layer 7 service that lives at Microsoft's edge points of presence, doing anycast routing, caching, and failover across regions. So the rule of thumb, Front Door spans regions, Application Gateway lives inside one region, and Load Balancer moves raw packets behind them. We start at the front. Create a Front Door standard or premium profile and define an endpoint with your custom domain. Front Door terminates TLS at the nearest edge POP to the user, which cuts latency dramatically for a global audience. Configure an origin group containing your 2 regional application gateways, one in East US, one in West Europe, with latency-based routing and health probes. Front Door will fail traffic over automatically if a region goes unhealthy. Turn on caching for static assets and the premium tier WAF if you want bot protection at the edge. This layer is your global front door, literally. Inside each region, deploy Application Gateway version 2 with auto-scaling enabled. This is your regional Layer 7 brain. Configure listeners on port 443, then path-based routing rules. Send /API to your backend pool of API virtual machines and everything else to your web pool. Enable the WAF policy in prevention mode using the OWASP core rule set to block injection and cross-site scripting before traffic reaches your apps. Lock this down so it only accepts traffic from Front Door by validating the X-Azure-FDID header, and restricting the public IP. Application Gateway also handles cookie-based session affinity if your app needs sticky sessions. Behind the gateway, the actual work happens. Say your API tier runs as a backend that needs to talk to a cluster of database or cache nodes over raw TCP. That's where the internal standard load balancer earns its place. It distributes Layer 4 connections across healthy backend instances using a hash of source and destination, with health probes pulling dead nodes out. It's cheap, it's fast, and it doesn't inspect payloads, which is exactly what you want for internal east-west traffic. Use the standard SKU, not basic, because basic is being retired and lacks zone redundancy and security defaults. Front Door and App Gateway never touch this layer. It's purely internal plumbing. Here's the choice people get wrong. If you only have one region and need WAF plus path routing, you don't need Front Door at all, just Application Gateway. If you're global but serve only static content or simple proxying without per path rules, Front Door alone is enough. No gateway. You combine them only when you need both global failover and regional Layer 7 control, which is our case. And never reach for Application Gateway when all you need is Layer 4 TCP distribution. That's Load Balancer's job at a fraction of the cost. Match the layer and the scope to the requirement, nothing more. Now confirm it works. Hit your Front Door domain from 2 different geographies and check the response headers. You should see the Xcache and the POP location reflecting the nearest edge. Pull one region's Application Gateway offline and confirm Front Door fails over within the probe interval, typically tens of seconds. Send a malicious test string and confirm the WAF returns a 403. Check Application Gateway backend health shows all green, and inspect the internal load balancer metrics for even distribution across nodes. Finally, send a request directly to the gateway's public IP without the Front Door header and confirm it's rejected. So the stack top to bottom, Front Door for global edge routing and failover, Application Gateway for regional Layer 7 rules and the web application firewall, and Azure Load Balancer for fast internal Layer 4 distribution. The discipline is matching scope and OSI layer to the actual requirement and chaining them only when each adds something real. Your one actionable takeaway: before adding any of these, write down whether you need global versus regional and layer 7 versus layer 4. That single sentence picks the service for you. Pricing and SKU features change often, especially front door tiers and load balancer basic retirement. So confirm against the current Azure docs before you commit. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.